We have 4 speakers today. I'm really excited to introduce them. We have John Gertzmeyer from ANT. We have Mike Jones from RRT Design and Construction, Pete Duddy from Solid Waste Authority of Palm Beach County, and Rodrigo Belisario from Titan America. I will now open it up to, we will start with John from ANT.
Thanks, Dana. Thank you for the round of applause, although we're the last group keeping you from being at the beach and or having drinks, so hold your applause to see if we can get through this quickly for you. Yeah, I'm John with AMP. We're going to talk today about how AI is transforming mixed waste processing and what we're doing today on the mixed waste processing front. So it's very interesting to hear the end of that last conversation and hear about all the trouble with contaminants in recyclables. So we're kind of looking at that from a different angle. We put in facilities to process recyclables, but also we'll put facilities in to process mixed waste. So then we get what we get, and we try to turn that into a recyclable pack that you'll see here in a second. So start with just a couple facts that are out there today. The world throws away, as they've estimated, almost $300 billion in materials every year, and with the one kind of far left at the bottom there, 87% disposable materials are landfilled or incinerated. So we're looking at how can we change that? How can we not just change the economics of recycling, but change the habits? And if we can't change the habits, then how can we create solutions that'll help us change this number as well? Where from the Recycling Partnership, they've estimated that 76% of recyclables are found in MSW today. So obviously that's a big problem just on a global scale, but here in the U.S. you'd think we would be better than that, and I don't know that we always are. And so we're looking at ways that how can we come in and change that? Again, if we've been telling and teaching and talking about recycling for, 20, 30 solid years here in the United States, and we're still not seeing big upticks in the numbers and how they change. This is our CEO and founder, Matanya Horowitz, and the main message there is that despite all the different stakeholders in the industry and the addition of technology and addition of dollars being committed to the recycling industry, we still really haven't seen those numbers change in the last 15 years. It's really been stagnant at what's actually being recycled. So what do we feel then are or are we seeing are the levers for change or the forces for change in the MSW space? And you really have those first two that are leading a lot of this, where a lot of it today is regulation. And you're looking at increased recycling, increased recovery requirements. You've got a lot of these municipalities and federal bills that might be coming out and saying, hey, we need to be at X% by 2028, X% by 2030, X% by 2035. And some of those numbers are massive. 50% diversion by 2030, 75% diversion by 2035. And processors and collectors, and I'm sure a lot of you in this room are looking at each other going, how can we do that? Like, there's just no way that we can get to those numbers. You couple that with a lot, obviously, around landfills and what that looks like, and there doesn't seem to be a big appetite to add more landfills in the country. So we're kind of on borrowed time with a lot of the landfills and how much capacity there is left in them. And then in the center, items 3 and 4 there, you've got an increased demand for net new recycled material. You still have, despite EPR and all of these things that are out there trying to change the habits of the people who create the packaging and things, there's still a huge demand for materials to be recycled and then reused again in new packaging. It's something that we've seen a change on and been able to capitalize on as well, and primarily in our Portsmouth project that we have, the emerging carbon market, where we've been able to create carbon credits and be able to monetize those based on the diversion that we're creating in a facility. And then the last two is really, where we're focused on this, is how can we add technology to improve sorting capabilities? What could new, project development models look like? How can we change the way things have always been done and make those numbers move that, again, we haven't really seen move in the last 15 years. So our AMP1 facilities are facilities that are highly based on technology. They can be used to process single stream materials or MSW. It's using our AI-powered jets, which are really AI-powered optical sorters. So you're using the power and kind of the workhorse ability of an optical sorter and adding AI to it, which just allows that system to grow, and the ability of that system to process and identify material to change at a much more rapid rate than it has with other tech that's been used in the past. We're doing this in space efficient and a modular design. So again, I've mentioned it at least once, but we are really trying to look at how do we change the economics of recycling. I think we've all seen project after project that comes out and is $50 million here and $75 million here. And I don't know that that's sustainable. I think we need to be looking at how do we bring down the cost of recycling, but actually increase the technology and the efficiency. So we're able to do that with the tech that we've designed and provide, and then creating space efficient modular design, so you can very easily increase the amount of material you're processing. These can be placed into existing facilities, so into a transfer station or into a building you might have at a landfill. Smaller spaces than have traditionally been. Sometimes the cost of the building is just too much to even consider, like trying to then buy a processing system to put it into the facility. So you can see at the bottom left, able to scale this from, say 50,000 tons a year to over 1 million tons a year. Again, your space constraints are a little different than the amount of equipment that you need. All driven in the center there by, the low touch nature of this, where, you've got a system that could process 50 to 100,000 tons a year and may only have 2 sorters on the pre-sort, just looking for really big, garden hoses, really heavy disc brakes and things like that coming through. I believe the days should be gone, or could be gone, of walking up to a MRF sorting platform and seeing 30 to 40 sorters up there, and people in very tough conditions to sort in, positions that are very tough to fill and not safe, and then creates kind of the biggest problem spot as you're trying to run a facility, is how do we continue to find labor to support this. And then if you look bottom, I've been pointing this whole thing the whole time and didn't realize I actually had a pointer on it, but if you look bottom right there, you can see being able to do this at 90+% recovery rates, at 98% uptime rates. And those aren't just rates that in our case, that we come in and say, hey, this system can do this, and then you buy it and you're stuck trying to figure it out. We come in, we will contract to those rates, so that we've got a contract that states this is what we'll operate at, and then can operate the facility as well to make sure that we maintain those numbers. Oops. Uh-oh. Oh, there it is. It's back. Thank you. I won't push the buttons anymore. So if you look on the right side there, you can see kind of how this model works, and really where you start to see the breakdown. You've got curbside MSW that's being picked up, which I do have a video at the end to show you real curbside going through the system. Curbside MSW being picked up, coming into a facility. From that facility, you really have the 3 main offtakes. You're still going to have a residue component that is just strictly, can't be used in organics, can't be used in, can't be recycled. That's kind of the worst of the worst. You've got on the right side there, then the recyclable fraction, which is what should have been in the curbside recycling, but isn't. So that's kind of your ISRI grade plastics, bottles, cans, papers, things that are coming through. And then in the middle, you've got the biggest component there, which is the organic stream. And that organic stream then, we would help to find a solution to that, so that you've got an offtake for what that organic solution would be. But what that allows, if you look, top left up there, being able to hit numbers of 60% plus diversion, because you're typically seeing a 15 to 20% recyclables component that you're able to pull out, and then you're seeing, maybe 40 to 45% organics component that you're able to pull out. So now, on every 100,000 tons, instead of taking 100,000 tons through a transfer station and sending them all to a landfill, now you might be sending 35,000 tons to a landfill and finding, homes for these others. You've got recyclables that you can see there that break down to the right of what kind of, you might see out of a traditional MSW stream. Those can be taken to a nearby MRF and then sorted to finished goods. So now you've got a revenue component that you've made out of that. And then you've got an organic solution that you can monetize as well. We've got a project in Portsmouth, Virginia. What we're doing there is taking the organics and turning it into biochar. Biochar is a carbon neutral filter, basically, that then municipality is using on their landfill for alternative daily cover. So not only have they reduced transload costs, they've extended the life of their landfill because they're putting less material in it. They've created an additional recycling revenue stream, and they've been able to offset their previous, alternative daily cover needs with biochar that's coming out of their own system. This is a video that I'll let you watch, but talk a little bit through. But this is our Portsmouth facility in a transfer station. What you'll see is, again, real curbside MSW here. This is not a demo site or anything like that. You've got real curbside MSW coming through. You've got it hitting a reducer on the front end, where it's liberating those bags and reducing the fraction of material down to smaller pieces so that the jets can see everything that's coming through. You've got a kind of a 2D, 3D separation there where you're looking at dropping the fines through and the organics. Got some pretty traditional pieces of equipment around, magnets and things that are still kind of the best of the best for pulling your metals. We've removed the big, star screens and things that cause many maintenance problems within facilities, so you don't have wrapping and things like that. You can see there a camera, you'll see some more of them, leading into these AMP jets, which is operating to separate the material as they come through, dropping out the residue, and then the cameras throughout the facility provide quality control so that we can see what's happening at any given point, how much material is going through, if we need to change a recipe at any given moment because a different type of materials coming in from maybe a commercial section of town versus a residential section of town. Then you get into here, you'll see on the right, you left where it started, on the right, what you end up with is that recyclables pack that you would then take to another facility, again, to be sorted out to finished goods. And in this case, again, the organics are coming out and being, taken to a biochar center where they're turned into biochar. All within the same place. So that's what we are doing today. Thank you for letting me speak to you. I think we're going to save questions till the end. Yeah, but would be happy to answer questions later or after the presentation.
Thank you, John. Next, we will have Mike Jones from RRT Design and Construction come up, followed by Pete Duddy with Solid Waste Authority of Palm Beach County.
Thank you, Dana. My name is Mike. I'm a project manager for a project engineer for all the Solid Waste Authority RMPF recycling facility projects since about 2011. That most recently, we need to get our, there we go. Sorry about that. I won't restart that. That's most recently the biggest projects, most recent upgrades was a 25 ton an hour container line upgrade project that was completed in December of 22, and the fiber line upgrade project that was just completed last October. Just a little bit of background on the facility itself. The authority's recovered materials processing facility is one of the largest in Florida, and is considered in the industry as one of the most efficiently operated facilities in the United States. It's a dual stream facility that began operations in 2009, 2010 timeframe, and currently processes over 100,000 tons a year of recycled materials, and that includes 40,000 tons a year of residential fiber and 20,000 tons a year of commercial fiber. The facility's been operated by Circular Services since 2019, and we've been the authority's engineer for the plant since about 2011. So these three esteemed groups work together for years now, and we formed the project team for the fiber line upgrade project. Challenges facing not just the facility, but the industry itself. Compositional and density changes to the inbound recycling stream over the last 15 plus years. It's no secret, nearly every recycling plant in the United States has dealt with it. We've all seen and spoken many sessions on it about the decreases in newspaper production and readership, the increases in the generation of cardboard from residents, and the increases in non-program materials, also known as trash, entering into the stream. And those are just a few of them, three of the challenges that MRFs have faced now. Over the 15 or so year life cycle of the authority's plan, a lot of that original equipment had reached near end of life, and a lot of replacement components were becoming harder and harder to procure. So to head off these challenges, the project team developed the fiber line upgrade project. We listed up here 5 of the key project goals. I'll just run through them real quickly. They included improvements to the fiber line throughput, maximizing recoveries of fiber and recovery of OCC cardboard as cardboard, real important, and minimizing the loss of that cardboard into the mixed paper. Along with it, we certainly wanted to increase the quality of mixed paper and cardboard. Another key goal was to increase O&M cost savings through increased automation, reduced maintenance, and reducing reliance on manual sorting. We also wanted to improve the feeding and safe transition of the fiber streams as it flows throughout the process systems, eliminating jams of cardboard, especially on the commercial in-feed and pre-sort operations. The new equipment was by MachineX, and it replaced and supplemented a lot of the existing equipment. And this stuff included new and larger in-feed systems for both residential and commercial lines. The residential in-feed included a new drum feeder to help feed the material better into the system. And the commercial in-feed was increased from 5 feet wide to 6 feet wide to handle the bigger pieces of cardboard. We also replaced the commercial fiber pre-sort line to make it a safer operation. The existing parallel fiber screens were replaced by 2 new smaller material recovery separation screens for recovery of small pieces of cardboard. There was also 2 new optical sorters that were added. The optical sorters are about 9.5 feet wide, and they use both VIS and near-infrared technology to detect and eject the browns. And as part of replacing the near end of life equipment, the existing baler in-feed conveyor system was replaced. And of course, with all this integration of new equipment with old equipment, the entire control system was replaced. Just run through quickly the contractual performance requirements that we established for the project. The residential fiber line throughput of 30 tons an hour, and that was to maintain the existing, what they would normally be getting. We increased the commercial fiber line throughput from 15 tons an hour up to 25 tons an hour. Systems availability requirement is 95%. That means no more than 5% mechanical downtime while the system is running. Recovery rate of OCC and browns was set for 90% recovery, and the purity rate of OCC and browns also set at 90%, and most importantly, that's without manual quality control, manual sorting of those materials. Just a little bit of project history. Several years ago, between about 2013 and 2016, RRT and the authority first planned the upgrade. We performed 3 very, very in-depth composition studies of the fiber streams. That wasn't just to find out the composition at the time, but to also observe the changes that happened over those 3 or 4 years. We also evaluated the quality of the corresponding quality of the materials that were being produced from those streams. In fact, I think it was in 2017 I gave a presentation here on the results of those studies and where our plans at the time were moving ahead. Some of you might have been here, might have been here to hear that. But with those results in hand, we set about exploring the capabilities of the optical sorter manufacturers and the sorting technologies at the time. So to make a kind of long story short, we concluded back in 2017 that the state of fiber optical sorting was not quite where we wanted it to be. And we made the group collectively kind of made the most fiscally responsible sense to hold off proceeding with the project for a few years in order to allow the fiber optical sorting technology to catch up to the needs of the industry. About 5 years later, with the Amazon effect fully in gear, and with Circular Services on board as the operator, the project team restarted the project with a series of fiber line studies in their plant as it was existing at the time. This helped us establish the benchmark production data, estimated the fiber stream composition and tonnages, both the current and the future, basically how those materials spread out throughout both the residential and commercial streams. Then we reestablished the goals and set the priorities for the project. Later on in 2023, we evaluated the facility itself, the hard assets of the facility, its capabilities for expansion, the condition of the existing equipment, and the available electrical capacity that the building had that would be able to allow for the expansion. RFPs were issued in early 2024, and with Circular Services being responsible for the overall project, and the equipment suppliers being responsible for all aspects on a design-build basis for the project. The project was awarded to MachineX with the project completion scheduled for fall of 2025. And from that point, the design, manufacturing, and delivery of the processing equipment were conducted all the way up through June of last summer. Construction and commissioning of the project. Installation was conducted over 10 weeks, 2 12-hour shifts a day, that's 24 hours a day, 7 days a week for 10 weeks through last summer to get the job done. Commissioning was conducted in September and October. This included wet and dry commissioning, operator training, ramping the system up, getting the tonnages up to where they were expected to be under normal operations, and then following that up with acceptance testing. And that was conducted, obviously, to verify compliance with all the performance requirements that were set. So the results, by the numbers, the results of the project. All contractual performance requirements and project goals that we had set out were successfully met. This slide kind of shows the table, the comparison of each of the performance requirements with the results of the acceptance test, which have been regularly maintained since October of last year. The plant now has significantly increased the throughput on the commercial fiber line. They've had a significant increase in OCC and Brown's recovery, along with improved product quality. We have reduced operating costs through labor and maintenance cost reductions and made some significant safety and material handling improvements throughout both systems. I'm going to hand it over to Pete to talk a little bit more about what's happened in the last few months.
Thanks, Mike. So good afternoon, everybody. I'm Pete Duddy. I've been in the waste and recycling industry for about 20 plus years. The recovered material processing facility manager for the solid waste authority since 2023. So as Mike stated, when we evaluated the project, one of the original goals was to improve OCC recovery, not simply process more tons. We knew that OCC was present in the fiber stream, but how effectively and efficiently are we actually recovering it? So as you can see, post-upgrade fiscal year to date 2026, OCC recovery nearly increased 33% year over year, while overall inbound tons remain relatively stable. It's important to note that the mixed paper decline year over year is driven by the upgrade itself, not the incoming tons. What changes our ability to identify and recover OCC that historically remained in the mixed paper stream. The upgraded optical sorters, enhanced processing systems are allowing us to capture more of that value, which is one of the objectives we intended to accomplish with this upgrade. One of the most significant outcomes of the project is a shift in our commodity mix. Historical fiber mix averaged approximately 60% mixed paper and 40% OCC, and that's remained stable for years. Fiscal year to date 2026, that relationship is flipped, with OCC now representing 58% of the fiber stream, and mixed paper has fallen to 42%, making OCC the majority commodity for the first time. We didn't start suddenly receiving more cardboard, we simply became better at recovering it. For me, that's one of the strongest indicators that the upgrade is performing as indicated. The tonnage data highlights the magnitude of the shift. Fiscal year to date 2023, mixed paper exceeds OCC by more than 8,000 tons. Fiscal year to date 2026, OCC exceeds mixed paper by more than 5,100 tons. That's a swing of over 13,000 tons between the two commodities. Today, that material is being identified, separated, and marketed as OCC, creating a much different value proposition for the facility. Recovery improvements only matter if they create value. OCC has consistently generated significantly higher value than mixed paper, even in today's market. Yellow sheet pricing, OCC is averaging about $70 per ton, compared to roughly $33 per ton for mixed paper. That's more than double value. While we can't control commodity markets, we can control how effectively we recover that material. The opportunity isn't higher OCC pricing. The opportunity is recovering a greater percentage of our fiber stream as OCC. The results of the project are clear. The fiber upgrade has improved OCC recovery, resulting in a more favorable commodity mix with a greater share of higher value material. This positions the facility to generate greater value from the same material stream moving forward. Next few slides are going to be some photos and videos of the upgrade itself. So this is a wide view of the upgraded fiber processing system. Here we have the new in-feed system designed to improve material flow and throughput. This is the new parallel screen configuration supporting higher processing capacity. These are the new AI optical sorters, increasing OCC recovery and commodity value. Here we have a short video. All right, well, it's supposed to be showing, the AI optical sorters, how they're identifying OCC in milliseconds and blowing over the separator drum with precision air jets. So there's two of them there. No, it says Kimberly.
Oh, it does?
I'm looking at the
You
bottom.
can see it.
No worries. I thought it was recorded. Oh, we took out the wrong video. That's all right. So this is the new baler feed in the back-end system of the processing system. Thank you for your time. I appreciate it.
Unfortunately, the slide that we thought we had in there was a side-to-side picture of the mixed paper bales that pretty clearly showed before 2024, before the project was pretty contaminated. Not contaminated, but it had a lot of browns in it, and the newest bales had very, very, very little cardboard in the mixed paper.
Thank you, Mike and Pete. This is some great information. And last but not least, you're the only one holding us up from a social tonight. So, we'll have Rodrigo come up and talk to us.
be as quick as I can.
No.
Well, I'm gonna talk a little bit about co-processing in cement kilns. Some of you might have been seeing this information, similar presentations, very similar to what we saw this morning from Kyle in the northern Florida, central and northern Florida. Our company is based in Miami, so it's more on the South Florida market, essentially a cement kiln. I'm gonna go a little bit over the details and benefits of co-processing in cement kilns as a landfill diversion alternative. We all have good wishes. This is a very well-intentioned group here, and everyone looking for innovative solutions, very good solutions, economical solutions. But the fact is that there are problems to get there, right? We know the problems of getting the contamination, the good recycling rates, getting our numbers together, and the cost to our operations, no? So in the end, what we all look is to avoid the generation of waste as much as possible, minimize that generation, whatever we can recycle. But then the fact is that most of that waste ends up in landfills, as has been shown by my colleagues here. No? Where co-processing meets is the simultaneous combination of a thermal process and a mineral recovery process within the cement manufacturing plant already established and already functioning. So we avoid the use of fossil fuels and mineral components like bauxite and calcium. Okay, it's not about competing against the alternatives that are already in the market. We empower recycle, we push for recycling as much as we can, but the fact is that there are many materials that can end in the landfills that can have a better use as a fuel for our cement operations. Titan America, we have 3 plants it's a European group, but with 3 plants in the United States, one in Pennsylvania that is focused on hazardous waste, another one in Virginia with 1 million ton capacity for non-hazardous waste, and our flagship plant in Miami, Florida is our Pensuco plant, which is the largest cement plant in the state and is the largest now that Sapphire Building 1 is the largest AF, an alternative fuels and alternative raw materials integrated plant in the state for non-hazardous waste with 250,000 tons of waste per year capacity. And we have a very wide logistic network because we distribute our materials through all the state, both coasts. So we have a lot of backhaul available. We have rail capacity available as well to move materials to our plant. And one of the benefits of co-processing on the cement kilns is that can be claimed 100% as recycling because we don't generate any byproduct. There is no waste generated. The only thing that isn't generated is the cement. Okay? And we operate all year with 98% reliability, meaning 98% of the year that plant is running and being used for making cement. Now, if you see basically the cement manufacturing process is taking the limestone and the different rock from the quarry, crush it, and cook it. Like you make a cake, basically, or a pizza. You put all the ingredients together, put it in the oven, and at the end you have a very, very delicious meal. The thing is that you don't eat this one. You mix it with water, rock, and you have a concrete, a sidewalk on a driveway. Okay? But the temperatures that on those processes reach is about 1600 Fahrenheit at the lowest, and about 3600 Fahrenheit the highest. That temperatures are the largest, it's the highest temperatures for any thermal process, destruction process, much higher than the waste to energy plants that we have several in the state. No? At the end, all that product, what comes out of that process, which is called a clinker, is ground with gypsum and other minerals, and that's the gray powder that you see in the bags in Home Depot and those. Okay? And when I say it's hot, it's because it's really hot. Those videos there are from our plant, and you can see that it's pretty much a man-made volcano. That is molten rock, basically. And now, how we compare with the other alternatives that are in the market? Typically, the landfill is a lot of methane released to the environment. It's a very poor energy efficient process. So a lot of land used for basically nothing. And yes, it's cheap. In this country, it's fairly cheap, no? Some facilities recover the methane to create some efficiencies of the natural gas, but the land use is very poor and they still have some more high operational costs. Waste to energy plants, even better, but at the end they produce ash that they have to dispose, and that ash is very difficult to dispose. So in the end, the waste of cement or the using cement kilns for producing, for making alternative fuels and replacing fossil fuels doesn't generate any ash. This process is completely waste-free because the ash gets incorporated into the cement. It's chemically bound to the cement that is being produced, so there's no leaching, no matter how fine, and you can see how fine we grind cement. It's a fine powder, so nothing is leached out of it because it's chemically bound to the mineral components of the clinker. So we reduce the energy, we reduce the minerals, and it's a plant already functioning, so our investment cost and our operational costs are much lower than the typical waste-to-energy plant or landfill plants. And if we compare, these are a little bit more some technical details on the temperatures that we reach. That is, again, is the 2,000 degrees Celsius for at the hottest point. And if we compare to the temperatures that are reached in the waste-to-energy plant, I don't see it here, but there you go. This is the hottest point of the process, which will reach a temperature of about 2,000 degrees. This is where the waste get in, and non-hazardous waste, which reach a temperature of 900 Celsius, which is about 1,600 Fahrenheit. And if you compare it to the waste-to-energy plants, we are much higher temperatures and for longer times. And those are one of the great benefits compared to the other alternatives that are in the market right now. So if we summarize, the long residence time at a high temperatures in a high turbulence environment ensure the complete destruction of all the organic components. So whatever we put in there, it is destroyed, completely destroyed. Combustion is reaching oxygen and active line, so that helps as a natural scrubber or as a process scrubber for the acid gases. So we ensure the emissions that come out of the combustion process are not harmful in any way. It's a high clinker mass. That plant in Miami produced 1.8 million tons of clinker per year. That is the largest plant, the largest single line plant in the state and the most modern one. That high clinker mass stream ensures that all the heavy metals that are present at the end in the ash of the combustion of the waste and is affixed to the matrix of the clinker, and there's no leaching from it, no? Because the ash is incorporated into the cement, into the final product, into the cement, is the only solution that is 100% zero waste or true zero waste solution. And all this happens in a highly technical and highly controlled environment. So we have continuous emission monitoring of our process or all our process variables, process temperature, pressure. So we ensure that all the process complies with the environmental constraints that we have in our permit. Okay? And now waste and the recyclables, and I'm gonna go later to what are the typical waste streams that we process in our cement plant. But in general, cement, because of the high temperatures and the high capacity of the cement plants, we can process a very wide variety of materials, no? And you can see there a few lists like the MRF residue, all plastic, any plastic except PVC, and tires, used oil, biosolids, and fly ash, gypsum, drywall. All those are materials that we currently, most of them currently do in our cement plant in Miami. Now, in 2019 and commissioned in 2021, we started our operations in our PEF plant, or process engineer field plant in Miami, with capacity again for processing incoming waste of 150,000 tons per year. No? is fully equipped to handle all the typical things that come out of the MRF and come out of the market in the non-hazardous arena. Is a primary shredder, secondary shredders, ferrous and non-ferrous separation, online analyzers. So we are monitoring everything that is being produced in terms of chlorine content, BTU content, and moisture content. Every single second that material goes to the plant, to the kiln, and being fed to the kiln. And because we extract value out of this waste, so we extract either heat value or mineral value, we are able to provide some much better cost than just disposing in the landfill. We can offset some of those costs that are processing. It's not easy, neither cheap to maintain a plant of this size. Nevertheless, we are able to get better tipping fees because we have some recovery of some of the investment that we made. And some of the materials that we process right now, and the MRF residue, whatever waste management out of their operation in Pembroke Pines, their new plant, whatever they cannot recover because it's contaminated, films, all that kind of things, they send it to us and we process it for them so it doesn't go to the landfill. And commercial, industrial, off-spec, paper, plastic, cardboard, even furniture. C&D material we process from waste management, C&Ds in the Miami area. We process all their wood, treated and non-treated wood, and plastic, HDPE mostly, roofing, carpet, and again, any plastic, as long as it doesn't have PVC. It's not that it cannot have a little PVC here and there, but in general terms, we avoid the PVC because the chlorine is very bad for the cement manufacturing process. And biomass, seeds, sawdust, you name it. And we blend all these things together to produce engineered fuel. Some people call it SRF, we call it process engineered fuel. But in the end, it's a blend of a careful blend of different waste streams received at the plant. On top of that, we also receive liquid hydrocarbons like used oil, and similars, and tires. In this case, tire chips less than 2 inches with no wire. We have agreement with some processors in the north and central Florida and Miami. They take the tires, they collect them, they shred them for us, and we are right now probably at 150 tons per day of tire chips, which is a humongous amount of tires. So in the past 10 years, since we have started with the Alternative Fuels Program at Titan, we have processed over 175,000 tons of tires, equivalent probably about 18 million tires. And in the case of a process engineered fuel, we have diverted over 75,000 tons from landfills, from different C&Ds and MRF operations, and over probably 5 million gallons by now of oil diverted also from going somewhere else. And bottom ash and fly ash, either from power plants or from waste to energy plants, about 250,000 tons per year. And some other industrial products like foundry sand and copper slag, mill scales, some different byproducts from different industry are things we try to get back into our process and take advantage of it. And we are exploring also now wallboard residue to extract the gypsum out of it, because every ton of cement that you see, every bag of cement, it has 5% gypsum. That is a formula that doesn't change at all. No? So we're trying to replace a portion of natural gypsum with synthetic gypsum recovered from drywall, and the paper goes as a source of energy as well. For the people in the water treatment plants, the water potabilization process, the lime residuals are also generated when they soften the water. All that lime is being thrown away or poorly disposed. We can use it and get it back into make cement out of it. No? And of course, recycling program, our concrete recycling program, where we take concrete and blend it with our own rock and market it as a new aggregate for for concrete as well, you know? And we are just expanding in the past year, and we expanded our feeding line so we can take full advantage of not only the material that we process, but other materials that can come already processed, already blended into our plant, and that's what increased our capacity to 250,000 tons per year. And on top of that, we still have unused capacity that we're still thinking what to do with it. Once we saturate our system, probably we can have still some investment to do, and add a little bit more to the mix and replace 100% of our fossil fuels waste. The end's 250,000 tons of waste that doesn't hit the landfill, is always better than zero. Okay. And I promise I was quick, so you can go on to the beach. So no questions? Thank you.
Thank you very much, Rodrigo. Just a reminder, I was thinking this, all of our speakers, not just these speakers up here right now, but all of our speakers at this conference, their biographies you can find in the app called YAPP, Y-A-P-P, if you haven't downloaded it yet, but you can find all the biographies in there. Questions? Right here.
For Rodrigo, one of your slides indicated that you can take biosolids, dried biosolids. Can you define what that means?
Our operations in Europe has been dealing with biosolid from water treatment plant for the past 16, 17 years, and it's something that we are looking to do here. There is very little experience in US in cement kilns. That was generous. There's none experience in cement kilns, but we know the technology, the temperatures that are there in the cement kilns can safely dispose, because we have been doing it in Europe, which is pretty much the same environmental standards as here. So it's something that we are exploring. It's not an easy topic because the material must come dry, the biosolids must come dry and pelletized to be able to be used as a fuel, no? But it's a great source of energy. It's a great source of mineral components, a lot of silica there. That was something that we use for making cement. And so we're in the process of evaluating, trying to get material to do some trials and partner with the environmental authorities, Miami-Dade, Broward, and our planning in Virginia as well. We also have some tailwinds there and trying to do a trial in the near future.
On moisture content, what do you need it at?
Around 10% pasteurized after a pasteurization process, because we don't want any heat generation for any biological activity when it's stored.
That could be really a big game changer from the PFAS perspective. So.
We know, and the PFAS topic is always the most sensitive issue, and that's where we are taking the right steps and partnering with local authorities, EPA, universities, research centers, try to bulletproof the steps that we are doing, so we can make sure it's too sensitive to treat it any other way. So, but it's coming. It's definitely, it's a solution. It's already there. It's already proven in the rest of the world. We just have to catch up.
If I can ask one question before we get to your question, I wanted to ask, probably this goes for you, Pete, actually. To what extent has there been seen an operating cost savings with the new technology? Does that make sense what I'm trying to say?
It does. So there's a reduction in manpower, which is obviously a labor savings. It's tough to put an actual dollar amount on it just because of everything.
You do percentage? So we don't, no, sorry. So we don't directly manage the facility, so we have a contracted operator who runs our facility for us. So that's why it's difficult for me to give you an exact dollar amount. There is a cost saving. Mary?
RT. Miriam Sims. I used to work at the Solid Waste Authority. That's where I started in 1992 and worked there for 5 years. So the interesting thing that I just want to make sure that I saw in the presentation, it seemed that the 30 tons per hour throughput didn't change. You kept that the same. Can you share why that decision, what the reasoning for that was behind the team?
There were some cost factors in there, but really the replacement of the end of life in-feed system is going to give them it has been giving them a little bit more flexibility, that they can actually run a little bit higher than 30. They can actually get up to 32, sometimes 33 tons an hour at some point. So, but they basically, to keep the rest of the city without adding additional sort rooms and a lot more infrastructure the decision was made to just keep that at 30 tons an hour and really enhance the ability for the commercial side, the commercial line to significantly go up 60% or something like that, increase on throughput.
Okay, thank you. And then I just have one question quickly for Rodrigo. Rodrigo, your presentation, I really enjoyed it, learned a lot, very innovative items that are, and obviously in this state where we count also energy recovery as a part of recycling. Can you give me a little bit more feedback on I think there was a feedstock, I think it's one of your newer feedstocks to be added. Can you tell me a little more detail on the seeds and sawdust, and who, is that the agricultural industry where and then the wood industry? Can you give me, so I understand that a little bit better, what that product and where it comes from?
Yeah, we don't receive it right now. We can, but we haven't been commercially engaged for agricultural products. We do receive a lot of wood from the CNDs. Probably 60 or 70% is treated and non-treated lumber from their operations, and because the MRF they don't generate any. We did a couple of projects of invasive species that they wanted to be shredded and destroyed and incinerated, and so there's a project with a Army Corps engineer where they clean some land and they send the material to us, but open to any those materials, seeds and hulls and that kind of things, have been proven to be a great fuel and a great source of silica for cement manufacturing for many, many years. They have done it in other plants, not in the plant in Miami.
So it's like a lot of those were wish lists for expansion down the road, if you could find the sources?
If the source is there, if someone wants to, or knows a source, or have in their power wheel some potential generators that want to dispose it with us, we have the technology and the capacity to do it right now.
Thank
Okay?
you.
I'm going to ask a question of John with AMP. So with AMP, you've got this unique perspective because you're not just building the technology, you're operating the facilities. So how does being an operator change the way you design and deploy the automation, because you'd have that insight from the floor, and how is that shaping kind of the next generation of MRF technology?
Yeah, good question, thank you. So it does give us a little bit of a unique perspective because, we, again, not that anyone else is actively trying to do anything like this, but when we go in and design a facility, we understand that we could be operating that for 10 or 15 years. So we have to look at that and say, what are future needs, or what could future needs be? Most of the changes, though, that we've seen are from the technology side. So we're putting in, pretty robust systems when it comes to belts and magnets and balers and other things like that. And then we're layering our technology on top of that. And then our technology allows us to make changes and kind of future-proof that MRF just through technology, without having to worry about going back in and making, physical changes to equipment, unless of course a piece of equipment fails or just wears out over time. But what you're really doing is putting out new updates, throughout the life of the system to create, could be, just additions to the AI, kind of knowledge and firepower. It could be adding new categories of materials. If someone were to say, if EPR comes through and someone says we want to collect toothpaste tubes, you know, you can make a lot of those changes just through the technology without necessarily having to go back in and make, you know, real material changes to the facility.
Thank you. Any other questions? I will say I learned a new word today. Clinker? Clinker. I'm gonna investigate that on Google and find more out about clinker. I had no idea that was a thing. Let's give another round of applause for all our people.